Welcome back, everybody. We're going to do HQ challenge number 27 today, and this is dealing with pre-analytical errors from an ABG. So if you're just learning to draw ABGs, we're going to talk about what large air bubbles do in certain situations. So the RCP notes a large air bubble in the syringe of an ABG drawn on a COPD patient with a saturation of 90%. All right, so if the patient's saturation is 90%, the oxygen hemoglobin dissociation curve tells me that this patient's P-AO2 is probably around 60 millimeters mercury. All right, so this is going to be important. All right, so which of the following would be expected? So this big air bubble is going to change the results of the blood gas. So let me show you how this works. It's going to be an ugly drawing, but you'll follow it. Okay, so let's say this is our ABG syringe and it's full of blood. And we have a great big air bubble in there. This air bubble is room air, okay? And this air bubble has room air oxygen in it, which creates a pressure of PO2, not PaO2, because that would mean in the arterial bed, but a pressure of oxygen in that air bubble of about 150, okay? This is that part of Dalton's law, barometric pressure minus water vapor pressure times the FiO2 comes out to roughly 150. And if you think about it, the air we breathe doesn't really have any CO2 in it, so the air bubble itself will be zero. Okay, this is the first thing you have to understand what happens when there's excessive air in the syringe. All right, so now in the blood, we know this patient's P-AO2 is about 60 because his sats were 90%. All right, and we don't know what the CO2 is, but CO2 will always do the same thing no matter what happens. So let's just pretend this person's CO2 is roughly around 55. Okay, so once you have this understanding, it really just becomes a matter of understanding that diffusion is the movement of gas from an area of high pressure to an area of lower pressure. Okay, so let's compare the oxygen. All right, the PaO2 the PO2 in the air bubble is 150. That's a high pressure. The O2 in the blood is 60. So this is going to facilitate diffusion from the air bubble into the blood. And so what will happen now is this will have an elevated P-AO2 because of that air bubble. So let's go over here to our slide, and we know the PO2 increases. So it's either this one or this one. All right, now let's come back over here and let's look at the CO2. And just think, diffusion moves from an area of high pressure to an area of low pressure. So what's going to happen with the CO2 is the CO2 is going to move out of the blood into the air bubble. And when it moves out of the blood, it decreases CO2, okay? Air bubbles will always, always, always decrease CO2, all right? And obviously, when CO2 decreases, that's going to increase pH. So now let's go back over here. We said it decreased CO2 and increased pH. So there is our answer. All right. So CO2, when there's an air bubble, CO2 will always decrease no matter what the CO2 is. CO2 will always decrease, pH will always increase. An air bubble will elevate. If the PO2 is below 150, it'll increase the PaO2 towards 150. If the PaO2 was already well above 150, let's say a patient had a non-rebreather mask on and getting 100% oxygen, the PaO2 was really high, and there was an air bubble, then it would bring down the PaO2 towards 150. So this is why we tell you, get your air bubbles out of the syringe when you draw an ABG. Hope this helps. See you soon.